Now, after the Pythagoras theorem, let's just move on further towards the converse of the Pythagoras theorem. So, what it states that it states in a triangle, square of one side is equal to the sum of the squares of the other two sides. Then the angle opposite to the first side is right angle, that is nothing but 90 degrees. So, let's just prove this particular theorem. First of all, we'll start with the given condition. What is given to us? So, given is actually a triangle ABC, a triangle ABC such that AC square is equal to AB square plus of BC square. This is actually a given statement to us, and let us suppose if I'm drawing a triangle over here which is nothing but ABC, which is ABC, and as you can see in this triangle ABC we have AC square is equal to AB square plus BC square, which is already given to us. And now let us suppose I'm just starting with the construction over here. So in order to prove that the angle is 90 degree, we have to do a particular construction. So let us suppose if I'm saying draw a triangle PQR right angled at Q, such that let us suppose if I'll draw a right angle triangle over here, and I'm calling it as P and Q and further R, which is a right angle triangle at Q, and I'm constructing this particular triangle in such a way that this side is actually equal to this side and this side is actually equal to this side. So I'm writing it over here such that PQ is equal to AB and QR is equal to BC. So we are taking this particular triangle in such a manner that these sides are equal to each other. Now let's just talk about to prove. What we have to prove? We have to prove that the angle B is nothing but is equal to 90 degree. So let's just start the proof of this particular theorem. So as you can see, if we are just talking about the proof of this particular theorem, we can see over here that we just wanted to prove that this particular angle is nothing but 90 degree. We just wanted to prove this thing that this angle is actually 90 degree. So let us suppose if I'm talking about these two triangles. So let's just start with it. In the triangle ABC and the triangle PQR, in both of these triangles, first of all we know about a particular fact that PQ is equal to AB, and we know the fact that QR is actually equal to BC. Now let's just talk about the triangle PQR. So we can say in the triangle PQR we can apply the Pythagoras theorem, and we can say that PR square is actually nothing but is equal to PQ square plus QR square. This is by the Pythagoras theorem. We can say this thing by the Pythagoras theorem that the square of the hypotenuse is nothing but is equal to the sum of the squares of the other two sides. Now from the equation number 1, let us suppose if I am calling this as equation number 1, then from the equation number 1 we can write this particular statement as PR square is equal to PQ. In place of PQ we can take AB, so this would be AB square plus of, in place of QR we can take BC, so this would be BC square. Let us suppose if I'll write, since we know that PQ is equal to AB and QR is equal to BC, so we can write this particular statement. Now let's just talk about the further one. So let us suppose if I am calling this equation as nothing but star and I am taking this equation as nothing but 2. So what can we say about these two? So we can say from the equation number star and from the equation number 2 we can say this thing that AB square plus BC square is equal to PR square, which is equal to AC square. Hence we can say that PR is nothing but is equal to AC. PR is nothing but is equal to AC. We can say this thing. Now again we can say if PR is equal to AC means this PR side is equal to this AC side. It implies that in the triangle ABC and the triangle PQR, PR is equal to AC. We have proved it earlier, proved earlier. And further we know PQ is nothing but is equal to AB, and we know that QR is equal to BC. This is actually the statement which is from the equation number 1. So hence all the sides are actually equal to the sides of the other triangle. So we can say that the triangle ABC is congruent to the triangle PQR by SSS congruency criteria. So it implies that if the triangles are similar to each other, then by CPCT their angles are also equal, means angle B is equal to angle Q by CPCT. And further we can say angle B is equal to angle Q. We know angle Q is nothing but 90 degree. It implies that angle B is equal to nothing but 90 degrees. So this is the thing that we wanted to prove. So hence proved the theorem that angle B is nothing but 90 degrees. So this is the converse of the Pythagoras theorem.